excited about the new GETT video series. My favorite hobby is drawing, as you can see in the background. And in the future, I plan to study in ophthalmology and make it big as an eye surgeon. So happy 20th anniversary, GETT!
Hi, my name is Naomi Hampson, and I'm one of the STEM educators at the YMWIC Foundation. My background is in physics from Westchester University and a PhD in materials science and engineering from Drexel University. I'm so excited to be a part of the GETT initiative this year.
Hi, my name is Asia Tillman. I'm a senior at Collegium Charter School. I joined YMWIC in 2018 through the summer program. I'm happy to join the GETT initiative, and I'll be a computer science major at Lincoln University in the fall.
One of my jobs as a STEM educator is to excite and engage the scholars about science. One way that we do this is to try to create science projects that relate back to the world around us. Now, in today's world, COVID-19 is on everyone's mind, and it's no longer safe to blow out birthday candles on a cake. So is there some other way that we could extinguish these birthday flames? Now, in this experiment, Asia has just combined vinegar with some baking soda. This reaction will create carbon dioxide. Carbon dioxide is a colorless, odorless gas, and it is heavier than air. So we're able to use that gas and pour it just like a liquid onto a lit flame. Let's take a look. The carbon dioxide, because it is heavier than air, makes it so that there's no oxygen available to keep the flame alight, and the candle goes out. Washing your hands with soap and water is extremely important, especially today. One of the reasons that soap is so effective at washing away germs is because it lowers the surface tension of water. Now, in this experiment, we're using pepper floated on the surface of the water to see what's happening to those surface molecules. Now, you're just going to go ahead and dip her finger in, and you'll see that at first, the surface tension is unchanged and the pepper sticks to her finger. Now she's going to go ahead and put some soap on her finger, and you will see that the surface tension is greatly reduced. And when that happens, the pepper flies away from the center where the soap is introduced as the surface tension is reduced. So in this trial, we are trying to get our autonomous robot to travel down a path, pick up a cube, turn back, follow another line, and drop that cube into a bucket. So I've been working on this code, carefully figuring out ahead of time what it is that I want it to do, and then testing to see if my robot is actually following what I've been thinking. So I'm going to go ahead and run it, and we'll see how it does today. And you'll notice it just missed grabbing onto the block. So the sensor that I used to try and find the block is what we call the ET sensor, which is a rangefinder. So it's looking ahead and trying to see where the object is, and at a particular distance that I set is where it would stop. So either my distance was incorrect, or it was finding it at an angle and wasn't seeing what I thought it was seeing. So a big part of robotics is trying to understand and think about what it is that your robot is seeing. Robots are very dumb. They're not doing anything other than what we tell them to do. So we have to carefully think through every single step of the way in order to get the robot to do what we want it to. All right, we're going to go ahead and run the code. First, it finds that black line, travels along the black line. I've told it to stop before it gets to the yellow block. At that point, it turns around, opens up the claw, moves forward, drops the claw down onto the cube, picks up the cube, turns back around, finds the black line, travels along it, and almost gets it in. Well, I guess this robot will never play basketball.
You can